Good morning, everyone. Welcome to session 2 of Investment Planning Specialist module. In today's session, we'll be learning about how to solve numericals. We'll be learning some of the functionalities that you need to use in the CASIO FC 200V calculator. Plus, I'm also going to teach you how to solve the questions, specifically the time value of money questions in Excel. Okay, so today's session is going to be interesting. So I'm assuming that you have the calculator, or at least you have access to Microsoft Excel, wherein we'll be doing some calculations. So first we'll understand how this compound function in the calculator works. So those of you who do not have calculator, you can note down the steps, and as and when you get an access to the calculator, you can practice this on your own. Okay. So compound function is by far the most important function in the entire CFP program. Lot of questions, numerical types are depend on how well you know the compound function. So we will start the session today by understanding how this compound function works. What are the different fields that are there, and what are the inputs required in each of the fields so that you get the right answer. Now, before I get into these fields, let me quickly go to the calculator and show you where do you see this compound function. So if you see this button, which is on row number 3, second button from the left-hand side, you will see CMPD, which is a short form for compound. Once you click on CMPD, you will see several fields over here. Now, I will help you to navigate this calculator. So there is a navigator in the center of this calculator with a top, down, right, left navigator. So since there are several fields over here, you just need to click on the down arrow and it will take you to the fields that are available. So I'm going to explain to you what each of these fields mean and what are the inputs required. Okay, so you can scroll up to the calculator. One thing you need to keep in mind is that whenever you're entering any figure, for example, let's say in this, you see in this N field, you see number 5, but let's say I want to type 3. Once you type 3, what you need to press is the EXE button, which is similar to the control button on the computer or laptop keyboard. So once you enter EXE, it will get entered. Okay, let's say I want to change the number from 8 to say 6. I type 6 and then I type EXE. So that is how my number will get entered. Suppose you see this black color background with a white color number or transparent number. That means you don't have to enter anything unless and until you want to enter anything. You can simply use this scroll key. Okay, if you already have this black color background with the transparent color number, that means you don't need to use EXE, because even if you use EXE, it's not going to work anything. EXE is going to be used only when you type the number. So let me show you this again. Let's say you have got 100 over here. You want to put 500. So just type 500. So you will see that the black background is missing. That means you have entered the number. Then you can press EXE. And now you will see that the number is entered. Okay. So this is how you can enter the number. Let's say you want to delete some number. Okay. So just click on delete and then you can type whatever number that you want. Okay. So let's say I want to delete this, click on delete, and I can type whatever number that I want. Else, what I can simply do is, instead of deleting, I can simply type my number. So number that you see over here is 5,236. Let's say I want to type any random number, 8,523. I can simply type that, it will get overwritten. So either you press the delete button or you simply press whatever numbers that you want, it will get overwritten. So it's up to you. How do you want to use this? Assuming that you know how to input the numbers, what is the reason why we press EXE, how do we scroll down? Okay. So let us go back and see what are the fields that are available and what are the inputs required. Now in this, if you see, the first field is set. Either the set can be begin or end. And mind you, this is the most confusing part of the compound function, wherein generally candidates are confused whether they need to use begin or end. I'm going to explain this to you with the help of an example. So typically in an investment, if you see, whenever you start an investment, you typically start today. You cannot have any investment wherein you open an investment, but you commit to the investment after a period, which means, let's say you go to a let's say you go to a bank and you tell the bank employee that you want to open a fixed deposit. Can it be possible wherein you tell the bank you open the fixed deposit today, but I will give the money after a month? It doesn't really happen. So in practical terms, it doesn't really happen. But from an examination perspective, in some scenarios, such kind of questions can come up where the cash flows are happening at the end of the period. End of the period means something in the future, not today. If something is happening today, let's say time zero today, then in that case, you have to take that set field as begin. Okay. But if something is happening at a later point of time in the future, then in that case, maybe that future is over here. In that case, set will be end. So this begin or end depends upon the periodic cash flow. Okay, what is a periodic cash flow? Something that is recurring in nature. Now, this cash flow can be an inflow, the cash flow can be an outflow, it can be anything. Okay, so if it is a periodic cash flow, you need to see when is this periodic cash flow happening. Is it happening today? In that case, the option that you need to choose is begin. In case if the periodic cash flow is happening at the end, that means at some point in time in the future, then in that case, the set that you need to choose is end. Okay, let me give an example. Let's talk about an annuity plan. Annuity plan is nothing but, in general terms, it is called as a pension plan. So in an annuity plan, typically what happens is you pay a lump sum amount to buy an annuity plan, and generally you get the first installment. I mean, you have an option as an investor whether you want a monthly cash flow, a quarterly cash flow, a half yearly cash flow, or a yearly cash flow. You can choose that frequency. Let's say you have chosen a monthly cash flow. So today you invest some lump sum, let's say that amount is 50 lakhs, and you've been assured to get a 50,000 rupees of monthly income. Now, this monthly income typically, unless and until you say that you need the cash flow immediately, typically it happens at the end of first month. So at the end of first month, you will get 50,000 rupees as a cash inflow. Okay. So in this case, if it is a regular annuity plan and you are going to get a monthly annuity, the first annuity starting after 1 month, then in this example, the set that you will be taking is end. Okay. Similarly, in case of a loan EMI, generally, whenever you take the loan, suppose you get the loan today, your first EMI will be after 1 month. Okay. So in this case also, your set will be end, because unless and until it is an advance EMI case, your loan EMI does not start immediately. Advance EMI is a case where today you get the disbursement of the loan amount and immediately you are paying the first installment. So in that case, set could be begin, but generally this doesn't happen. In a regular loan, you get the loan today, but your EMI starts typically after 1 month. So because that is a periodic cash flow, of course, it's a loan EMI payment, which is recurring. And since it is recurring, you need to see what is the frequency of the recurring, in the sense, when is it happening? Is it starting today or is it starting at a later point of time? If it is starting today, then it is said begin. If it is starting later, then it is said end. Let's talk about a recurring deposit. Now, in a recurring deposit, it typically starts today, right? Unless and until you invest, you put your first installment, the RD is not going to start. So in this case, RD typically is begin. Okay. Now, this is how practically this set begin or set end works. Now, from an examination perspective, you need to be careful. Uh, once you have the question, read the question and try to see what is the frequency given. Typically, in the question, the frequency is mentioned, not directly, but indirectly. What would the question say? That the investment will start one period later. If that is the case, you need to take set end. If it is mentioned in the question that the investment will start today, then it is set begin. Okay. Or if the question says the cash flows will happen at the end of every period, then of course it is set end. Or if the question mentions that the cash flow will start at the beginning of every period, then it is set begin. So you need to be careful in the examination what has been given in the question and go as per that. Okay. But practically, whatever I explained to you, this is how it works. Now, what is the impact of this set begin and set end on the end result? You will see that impact when I explain to you the other parts of this compound function. But for now, what you need to write is set could either be begin or end depending upon the time period of payment. When I say payment, I'm talking about the periodic cash flow. Okay. So how do you change that in the calculator? So if you go to the compound function, you will see this set as end. Let's say you want to change this set from end to begin. How do you do that? You press the EXE button. On the bottom right-hand corner, you will see this EXE button. Once you press this, you'll get into the set option, wherein you'll get two options. Option number one is begin, and option number two is end. You can use this scroll key to either choose begin or end. Let's say you want to choose begin. So you choose begin and then again press EXE button, which works like a control button of your computer or laptop keyboard. Once you choose execute, you will see that set has been changed to begin. Let's say again you want to change set from begin to end. Again, you press the EXE button, use this down scroll key, which is end, and again press the EXE button. And that's how you will see that set has been changed to end. Let me get it back to begin. So this is how the set needs to be changed in the compound function. Going back to the other fields of the compound function, the second field, which is N, that stands for number of payments. Now, if you actually look at any kind of investments or any kind of cash flows, either the cash flows could be recurring in nature, or the cash flows could be one time in nature. Okay. So depending upon the nature of the cash flow, your N will be dependent on that. So in case of the cash flow being recurring, N will be the number of payments or cash flows. And would this cash flow payments be an inflow and outflow? It can be both. In case of an investment, it can be an outflow. In case of an EMI, it can be an outflow. In case of a pension plan, it can be an inflow. So whatever number of total payments that are there or cash flows that are there, that number you will put it in N if the cash flows are recurring in nature. However, if the cash flows are one time in nature, then in that case, N will be the number of years. Okay, so that's the basic difference. Now, let's say you are investing in a fixed deposit for a period of 5 years. And simultaneously, you are opening a recurring deposit. And this recurring deposit is also for a period of 5 years. Okay. And assuming these are monthly recurring deposits. So if you have to determine n. What will be n in this case? And what will be n in this case? Can you put your answer in the chat box, please? In case of a fixed deposit for 5 years, what will be n? And in case of a recurring deposit for 5 years, what will be n? Please put your answer in the chat box. You need to put the number. What number will you put in n? Okay, quickly put your answer in the chat box, please. What do you think? Okay, so in case of fixed deposit, n will be the number of years. So since this fixed deposit is for a period of 5 years, n will be 5. In case of recurring deposit for 5 years, since it is monthly, you need to know how many contributions will be there in 5 years. Since it is 12 contribution in 1 year, in 5 years, there will be 60 contributions. Okay, so here in this example, n will be 60. That is the number of cash flows over a period of 5 years, since these are monthly recurring deposit. Okay. Again, let me give you one more example and tell me what will be your answer. Let's say you are investing in an insurance policy, and it's a one-time payment. And this is for a period of 20 years. Okay. On the other hand, let's say you are paying a loan EMI for a period of 4 years. Tell me what will be n. In case of insurance premium, which is paid one time, what will be n? In case of loan EMI paid for 4 years, what will be n? Put your answer in the chat box, please, everyone. Perfect. So in this case, in case of an insurance premium, since this cash flow is one time and is going to be there for 20 years, so n will be 20. In case of a loan EMI, since these are monthly EMIs for 4 years, so in 4 years, there'll be 48 EMIs paid. So n will be 48. Okay. Good work, everyone. So that's how you determine n. Then the next field is I percentage. Now, in this case, whatever number that you're going to put is always the nominal annual rate. What do I mean by nominal annual rate? Let's say there is a bank which offers 5% compounding, or let me put this as 6% compounding monthly. Okay. Now, what is going to happen over here is that this 6% is nothing but the nominal rate. However, when you calculate what is the effective rate of this 6%, it will be something else, and it will be definitely more than 6%. Okay. Now, how do you calculate what is going to be the effective 6% rate? It's quite simple. So it will be 1 plus 6% divided by the compounding frequency. So how much is the compounding frequency? The compounding frequency is monthly. So in 1 year, it will compound for 12 times. Okay. So 1 plus 6% divided by 12 raised to 1 into 12. If you remember, in the last session, we learned that the formula for calculating the future value of the present value, one of the component was 1 plus r upon 100 raised to n, where r was either the rate of return or it was the rate of inflation. Rate of return was in case of investment, and rate of inflation was in case of expenses. And N was the number of compounding periods. So this works well when the compounding period is annual. However, if the compounding period is anything but annual, then in that case, you need to find out what is the effective return. So that is what we are doing over here. Let's say there is some investment that you're making at 6% compounded monthly, which means in effect, if this compounding happens monthly, after 1 year, you will receive more than 6% effective return. So we need to calculate what is that return that you'll be getting, say, after 1 year. So what I simply do is the rate of return, I will divide it by 12 because it is compounded monthly. And then this investment is for a period of 1 year. And in 1 year, there are 12 number of compounding periods. So if I just go to the next step of this equation, it will be 1 plus 0.50%, okay, which is 6% divided by 12, and then raised to 12. Okay. If I convert this percentage into decimals, then it will be 1 plus 0.005, okay, raised to 12. Now, mind you, it is 0.005. If you put it as 0.05, that will be considered as 5% and not 0.5%. So you need to convert this into, you need to convert this percentage into decimals by dividing it by 100. So when you do this, what you finally get is, next step, 1.005 raised to the power 12. Okay. So how do we do this in the calculator? Simply press this on button. You'll go to the main screen of the calculator. Type 1.005. Press shift. Press 6. You will get a raised to sign. Type 12. Close the bracket and press execute. What you're getting over here is 1.061677,812. So since you have added 1, you will do a deduction of 1. Once you deduct 1, you will get 0.0616. I will tell you why I deducted 1. And then simply convert that into percentage by multiplying it by 100. So what you're getting is 6.1677%. So the effective answer is 6.1677%. So this is the effective return. Okay. So because of the compounding frequency, you're getting this 0.1677% extra. Now, if I solve this, I got 1.061677%. Now, why did I do a -1? The reason I did a -1, because if you see over here, I had added 1. Okay, so I have to deduct that 1. So after I deducted 1, what I got was 0.061677. And then later on, I multiplied it by 100. Why did I multiply it by 100? Because I converted this percentage into decimals. Again, I have to convert these decimals into percentage. So if I divide to convert the percentage into decimals, then I have to multiply it by 100 to convert the decimals into percentage. So it will be 6.1677%. This is the effective interest rate. So what simply you need to do is, you don't have to worry about putting the effective interest rate in the calculator. The calculator will calculate that automatically. What you should be putting is only the nominal rate. Every time you put the nominal rate, irrespective of what is the compounding frequency. For example, if the return is 8% compounded quarterly, what number will you put in? Can you please tell me in the chat box? If the rate is 8% compounded quarterly, what number will you put it in the chat box? In please mention your answer in the chat box. So 8% is compounded quarterly. Will you put 8? Will you put 4? Will you put 2? Or will you put something else? So here the answer is you will put 8% only. You don't have to, I told you I just explained the difference between nominal and I explained the difference between the effective rate. But when it comes to inputting your number in this field, which is I percentage, it will always be the nominal annual rate. So in this example, 8% compounded quarterly. So 8% is what you put. If it is 12% compounded yearly, then you will put 12%. If it is 3% compounded half yearly, you will put 3%. Okay. So just put whatever is the nominal rate. Don't worry about this compounding frequency. I will tell you where you need to input the number so that the calculator knows whatever is the compounding frequency. So I'll tell you that in a moment. But before we get there, always remember that this number will always be the nominal rate. You don't have to worry about the compounding frequency, nominal, and that too annual nominal rate. Okay. Suppose you want to calculate the compounded frequency. So let's say 8% compounded quarterly. You want to calculate the effective return. Okay. Although you don't have to worry about that, but let's say you want to calculate the effective return of 8% compounded quarterly. What you're going to simply do is 1 plus 8% divided by 4 divided by say 100% raised to 1 into 4. So it will be 1 plus 8% divided by 4 is 2%. 2% divided by 100% raised to 1 into 4 is 4. Then this will be 1 plus 2% divided by 100% is 0.02 raised to 4. And then it will be 1.02 raised to 4, which will give you 1.02 shift 6 raised to 4, close the bracket and press execute. So you'll get 1.0824. 1.0824. So simply minus 1 and then multiply this by 100. And if you solve this, what you're going to get is 8.24%. Okay, so 8.24% is the effective rate. Okay, it is the effective rate, but you don't have to worry about the effective rate because the calculator, once you have one more input, the calculator knows what to calculate, how much to calculate. Okay, so in this, you will still put 8% and not put the effective rate because effective rate the calculator will calculate. Okay, I'll tell you how in some time. Okay, I hope you're clear with these three inputs. What do you put in set? What do you put in N? What do you put in I percentage? Now let's move on to the next factor, which is the present value. PV stands for present value. So what amount you have today? Okay, now it is important to know whether that amount you're getting as a cash inflow or you're getting that as a cash outflow. So anything which is coming as an inflow, that number you'll put as a positive number. Anything which is going as an outflow, you have to put that number as a negative number. Okay. For example, suppose you have taken a loan. You have taken a personal loan. What will happen to that amount? That amount will come into your account. So it is a cash inflow. So let's say you have taken a personal loan of 3 lakhs. So you'll just put 3 lakh rupees over here, which is a cash inflow. In case if you have invested, let's say you have invested into a mutual fund, a one-time amount of 1 lakh. So that amount, since it is an outflow, you will put it as minus 1 lakh. Anything that is going out of your pocket has to be a negative number. Anything that is coming into your pocket has to be a positive number. And this is very, very important for you to remember, because if you make any error in this, your answer will not match. Okay. So remember, if it is an inflow, the number has to be positive. If it is an outflow, the number has to be a negative number. So this is typically for investments. Any kind of investments will take money out of your pocket for that moment. Any kind of maturity of investments, or say any kind of loan, can be an example wherein the cash is coming into your pocket. So that will be positive. Okay, so present value is very, very simple. Okay, then the next field is PMT, amount of periodic payment. Now here present value is one time. So this inflow and outflow is one time. Only if it is one time, that number will be put in PV. If it is a recurring investment or recurring income, so those things will not be put in PV. PV is only meant for one time. Please remember this, because a lot of candidates make mistake over here, wherein one time they put somewhere else and here they put periodic. Okay, so if it is one time, only then that number comes into PV. It can be an inflow or an outflow. If these are recurring, then it doesn't come into PV. Okay, PV is no recurring, so PV is lump sum or one time. So this is correct. Recurring, so in PV you don't put any recurring amount. It is only one time or lump sum amount. Okay, I will give you some examples for you to understand this better. Next is PMT. PMT is the amount of periodic payments. Again, here, depending upon whether it is a cash inflow or a cash outflow, we either put it as positive or negative. Meaning, suppose you're investing in a mutual fund via SIP, an amount of 10,000 rupees per month. Okay. So will this amount go in PV? The answer is no. Why it will not go in PV or present value? Because 10,000 is not one time. It is every month. So this amount will come in PMT. What will you put this 10,000 as? Will it be positive or negative? What do you think? Let me know in the chat box. Will this 10,000 be positive or negative? I want everyone to answer, please. So it depends whether it is a cash inflow or an outflow. If it is an outflow, it will be negative. If it is an inflow, it will be positive. So what do you think? Is it an outflow or is it an inflow? Whenever you are investing, is money going out of your pocket or is money coming into your pocket? If it is going out of your pocket, it will be negative. If it is coming into your pocket, it will be positive. What do you think PV should be? Sorry, PMT should be. Should it be minus 10,000 or should it be plus 10,000? What do you think? Quickly, tell me your answer. That's right. So it should be minus 10,000 because this money is going out of your pocket. Okay. Now, let's say you have invested into a pension plan, some X amount, and you are getting a quarterly pension of 25,000. What will you put this as? Will you put this in PV or PMT? What do you think? Will you put this in PV or PMT? PMT stands for payment. Will you put it in payment? Will you put it in present value? What do you think? Quickly. I want everyone to answer, please. PMT or PV? So this will come in PMT. Now, why it will come in PMT? Because it is a recurring cash flow. And will this amount be shown as positive 25,000 or negative 25,000? What do you think? Put your answer in the chat box. Will this be shown as positive 25,000 or negative 25,000? Think of it, whether it is an inflow or an outflow. If it is an inflow, it has to be positive. If it is an outflow, it has to be negative. Since it is a pension plan and you're getting some periodic pension in your hand, it's an inflow. And since it is an inflow, PMT will be positive 25,000. Okay. I hope this is making sense. Let's talk about a loan EMI. Let's say there's a loan EMI wherein the monthly EMI is 3,000 rupees. Where will this come and what will be the sign? Will it come in PV or PMT? And will it be positive or negative? Quickly tell me your answer in the chat box. Will this come in PMT or PV? And will this be positive or negative? Pankaj, you can put your question in the chat box. Whatever question that you have, put it in the chat box, please. Okay, so it will be PMT since it is recurring EMI. And since this is an outflow, PMT will be minus 3,000. Okay, so that's the input. Good. Then comes the next field, which is future value. Future value stands, FE stands for future value. So here you will put whatever amount that you will be getting in the future. And in all probabilities, the amount that you will be getting in the future will be an inflow. Very rarely it can be an outflow, which I'll explain to you in some of the examples later at a later point in time. But for now, whatever money that you will be getting at some point in time in the future will come in FE. And since this is a one-time amount that you'll be getting in the future, that amount will come as a positive or a negative value. So if it is an inflow that you're going to get in the future, it will be a positive value. If it is an outflow that you are required to make in the future, then it will be a negative value. I will explain to you what are the scenarios wherein this FE can be negative, but at a later point of time. Okay. So for now, just remember that anything that you're going to get in the future, that amount will come over here as a positive number. Moving to the next field, P/Y, that stands for payments per year. Okay. Now, if you talk about any kind of payment, that can either happen monthly, it can happen quarterly, it can happen half yearly, or it can happen yearly. So in case if the payments are happening monthly, then in 1 year, you have 12 number of payments. In case if the payments are happening quarterly, then in 1 year, you have 4 quarterly payments. If the payments are happening half yearly, then in 1 year, you have got 2 6 months or 2 half years. So you will put 2. If the payments are happening yearly, so in 1 year, there will be 1 payment. Okay. So depending upon the payment frequency, you can either put 12 or either put 4 or either put 2 or either put 1. Okay. So that is what, I mean, the number will be determined depending upon the payment frequency. Does this make sense? Okay. This is what I've mentioned over here. And the last field, which is C/Y, which is compounding periods per year. Again, the compounding frequency could be monthly, could be quarterly, could be half yearly, could be yearly. So if it is monthly, you have to put 12. If it is quarterly, you have to put 4. If it is half yearly, you have to put 2. And if it is yearly, you have to put 1. So if I just go back to this example, okay, wherein the interest was 6% compounded monthly. So in order to give the effect of 6% compounded monthly, what you simply have to do is in I percentage, you have to put 6, and in C oblique Y, you have to put 12. So the moment you put 6 over here, which is the nominal annual rate, and you put 12 in compounding per year frequency, the calculator will calculate what is the effective return, which is this number that we calculated manually. Okay. The only thing you need to do is give the right input to the calculator. The calculator at the back end will calculate what is the effective rate. Similarly, if you wanted to find out a question's answer wherein the interest rate was 8% compounded quarterly, then in that case, I percentage would have been 8 and compounding per year would have been 4 because it is quarterly compounding. So the moment you put 8 in I percentage and 4 in C by Y, the calculator will automatically calculate whatever is the effective return of this 8% compounded quarterly kind of a return. Okay, so this is how the C by Y works. Now, this is how practically it works. Now, from an examination perspective, there is a little difference. Okay, now keep this in mind that in examination, whatever number that you put in P by Y, the same number you will put it in C by Y. For example, if the payments are happening monthly, so in P by Y, you will put 12. In C by Y, also you will put 12. Okay, this is from an examination perspective. Okay, there's a little different way in which it is calculated. Practically, you look at practically your payment per year and compounding per year could be different. Okay, let me give you an example and I will tell you why this matters. If let's say in the examination, if the payments are mentioned quarterly, so you will put 4 in payment per year and in compounding per year, you will put 4. Okay. So whatever number that you have in payment per year, the same number you will put it in compounding per year. You will not have any variation. This is only from an exam perspective. Okay. Only from exam perspective, whatever number that you put in P by Y, the same number you will put it in C by Y. Okay. Let me give you an example here. Let's say you are investing into a recurring deposit, an amount of 4,000 every month for 3 years, and the interest rate is 7% compounded half yearly. Okay, so these are the inputs. Now, I'm going to show you 2 things. One, how do you do this practically? And 2, how do you do this from an examination perspective? So let's understand how do you do this practically. Now, set is begin. Why begin? Because if nothing is mentioned, by default, you have to take set as begin. Okay, there is a variation here also from the examination perspective, which I'll tell you in a minute. So set is begin. N will be the number of payments. Since this is a recurring deposit, it is a periodic cash flow. So N will be the number of such cash flows. So in 3 years, how many cash flows will be put? 36. 12 cash flows every year. So 36 cash flows in 3 years. I percentage will be the annual nominal rate, which is 7. PV is 0. Why 0? Because it's a recurring cash flow. It is not one time. Since it is not one time, PV will be 0. PMT will be minus 4,000. Why minus 4,000? First of all, it is a recurring cash flow. And second, such cash flows are getting invested, which means it is an outflow. So it will be minus 4,000. FV is something that you need to calculate. How much will you get after 3 years? P oblique Y will be 12. Why 12? Because these are monthly recurring deposits. So in 1 year, there'll be 12 installments. And C oblique Y will be 2. Why 2? Because these are compounded half yearly. Okay, that's where it will be 2. In case of an examination, set ideally should be begin, but in some cases, it could be end as well. Okay, so if you're not getting an answer with set begin, with whatever logic that I told you, if you're not getting an answer, try choosing set end and you will have that answer. So either it will be with begin or end, because there is a different way the examination calculates this, because the calculator that is used is a Texas calculator, and in Texas calculator, the by default method is end, and that's the reason most of the calculations are shown as end. Okay, but you follow whatever I told you at the beginning of the session, the concept for choosing set, either begin or end. But let's say for any reason you're not getting an answer with the concept that I mentioned, just try reversing that. So as per the concept, let's say you chose begin and you got the answer, but that answer is not matching with one of the available options, then you simply change that begin to end and then solve, and definitely you will have that answer. It will never happen wherein you will have the answer with begin as well as end. Very, very rarely that could happen. Okay. And that will happen only when it is clearly mentioned that what frequency you need to use, and then you have not taken that frequency. In the sense, it is clearly mentioned when is the cash flow happening, whether it is today or later. And if you still ignore that and take a wrong begin or end, then it could happen. Otherwise, if nothing is clear cut mentioned, then choose begin. If you're not getting the answer, then choose end. I know it is a little difficult to remember this, but this is how it is in the examination, and practically things are different. So moving on, N will be 36. I will be same, the annual nominal return of 7%. PV is 0. PMT is minus 4,000. FE you need to calculate. Payment per year is 12. And here compounding per year is also 12. This is from an examination perspective. Like I told you, whatever number that you put in P by Y, the same number you put it in C by Y. Okay. So where is the difference? The difference is over here. And the difference is over here. Okay. There could be a possible difference in set, but there'll be a definite difference in C by Y. Okay. So this is how you need to calculate. Now I'm going to demonstrate how to get the answer in the calculator. But before I do that, I want you to write this down in your notebook, and then I will show you how to calculate this in the calculator in the compound function. Okay, so I'm giving you a few minutes. Please note it down. I'm pausing the video. So assuming that you're done writing this example, now I want you to also write this down. Okay, the compound function steps, please note it down. I'm giving you a few minutes to note it down. Assuming you're done writing, now let's learn how to calculate this in the calculator. So first we will learn the practical way, then we will learn the examination way. So what you need to do is click on CMPD, see what your inputs are and try to override those inputs if required. So set will be begin, N will be 36 because this RD is for 3 years, so there'll be 36 periodic payments. I will be 7%, which is the nominal annual rate. PV is 0 since nothing is invested one time. The recurring amount is 4,000 rupees, so it will be minus 4,000. Future value, let's keep it as 0 because we need to calculate this. Then payment per year is 12. Compounding per year is 2 because this is 7% compounded half yearly. So this is how you calculate practically. Okay. So once you have input all the values, it's good to check whether your input values are correct, because in case even if one input is incorrect, it might lead you to an incorrect answer. Okay. So after checking that, let's say we need to calculate FE. So once you have your cursor on FE, you need to use this blue color button called as solve. Just press this, and when you solve, you will get the answer, which is 1,60,397. How did you get this answer? By taking your cursor to the FE field. So whatever is the answer that you need, take the cursor over there and press this blue color solve button, and that is how you will get the answer. So 1,60,397 is the answer. So 1,60,397 is the answer, the practical way. Now, let's understand if it was in the exam, then how you would have calculated. Then in that case, C by Y would have been the same as P by Y. And then rest everything would have been the same. And then press solve. You are getting 1,60,652. 1,60,652. There is a marginal difference in the answer because of the compounding frequency. So from an examination perspective, this is your answer. From a practical perspective, this is your answer because you're taking into account the compounding frequency as given in the actual scenario. Okay. Now, what if in the examination, it was mentioned that the cash flows are invested at the end of every period? Okay, then in that case, what you would have simply done is change the set from begin to end. How do you do that? Take the cursor to set, press the EXE button, use the scroll key to choose end option, press the EXE button again, scroll down and go to future value and press solve. And that's how you get the answer, which is 1,59,720. So if this was set end, then the answer would have been 1,59,720. So the answer would have been a little less. Okay, so that's how the set begin and set end concept works. Any questions, anyone, on the things that we have learned so far? Okay, so since there are no questions, let's move on to the next concept, and we will also be solving some questions. So first concept that we learn after understanding how the compound function works is to calculate the present value or the future value of a fixed annuity. Whenever you see this term annuity, it means that there are some regular cash flows coming. So this annuity could be in a context of an annuity plan or a pension plan, or it could be in a context of any recurring cash flows that you are getting. Okay. So here we will be learning how to calculate present value of a stream of cash flows that you'll be receiving in the future, or how to calculate the future value if you are going to invest a stream of cash flows and that amount is going to get accumulated in the future. So both of these things we will be calculating. Before that, let us read this statement. So present value of an annuity is nothing but the current value of the future payments of an annuity given a specified rate of return or discount rate. The higher the discount rate, the lower the present value of the annuity. What this simply means is that suppose you will be getting 50,000 rupees for the next 5 years. So year 1, year 2, year 3, year 4, year 5. Suppose this is the series of payments that you will be receiving. You want to find out what is that one-time amount that you put today, that is present value, so that you get this cash flows over the next 5 years. Now, you might want this cash flows beginning immediately. Or you might want this cash flows later at the end. later at the end. Okay. So if I draw a timeline and I plot this cash flow, let's say this is today, time 0, time 1, time 2, time 3, time 4, time 5. So 1, 2, 3, 4, 5. You can either want this cash flow starting today, which is 50,000 now, 50,000 after 1 year, 50,000 after 2 years, 50,000 after 3 years, 50,000 after 4 years, so on and so forth. So if this is how you want, it will be set begin. However, if you need the cash flow one period later at the end, then your first cash flow will come at the end of 1 year. Second cash flow will come at the end of 2 year. Third cash flow will come at the end of third year. Fourth cash flow will come at the end of fourth year. And fifth cash flow will come at the end of fifth year. Now, this period is basically 1 year. So ending of 1 year is also the beginning of second year. I repeat, this period between 0 to 1 is the 1 year period. Ending of 1 year is also the beginning of the second year. This period is 2 years. So ending of 2 year is also the beginning of third year. This period is 3 years. Ending of 3 years is also the beginning of 4 years. This period is 4 years. Ending of 4 years is also the beginning of 5 years. This period is 5 years. Ending of 5 years is also the beginning of 6 years. Okay. So you need to determine whether you need the cash flows today or at the end of the period. If this is what you need, then set will be end. Okay. If you need the cash flows at the end of every year, then it is set end. If you need the cash flow at the beginning of every year starting today, then set is begin. Let's assume that the rate of return that you earn on this is 10%. Rate of return is also sometimes called as the discounted rate. So using this rate of return, you want to find out what is that amount of money that you need to have today, that is present value, so that you will be able to get this cash flow wherein the amount that you have today will keep on earning 10%, okay, which is the rate of return or the discount rate. So how do we calculate this? We use the compound function. So let's assume that you need the cash flows beginning immediately. So set will be begin. N will be 5, since you need 5 annual payments of 50,000 each. I will be 10%, assuming this is compounded yearly. Whatever is the compounding frequency, in I, you will always put the annual nominal rate, which is 10 in this case. PV is something that you need to calculate. PMT is the amount of periodic cash flow. Okay, so it will be 50,000 rupees positive since you're getting the money as an inflow. Future value is 0, since after 5 years, you are not expected to get anything in the future. Payment per year is 1, since you're getting this annual cash flow, and compounding per year is also 1. So this will be your input and you will solve this in the calculator. So let's do this. So set, I need to change from end to begin. Press the EXE button, choose set begin, and then press EXE again. So your set has been changed from end to begin. N will be 5, I will be 10. So after you input all the numbers, you have to press the EXE button. PV is what you need to find out. So let's keep it at 0. PMT is 50,000 rupees. Then future value is 0. Payment per year is 1. Compounding per year is also 1. So after you have input all the fields, you check whether you have done the inputs correctly, and then go to PV. That is where your cursor should be, and press the solve button. When you do that, what you get is 2,08,493. Okay, so 2,08,493. Yeah. So why it is showing as negative? Because if you invest this money today, then 50,000 rupees is the cash flow which will come over the next 5 years. Okay, that's why since it is an investment, this number is showing as negative. Now for the calculator, the moment you put PMT as positive, it will consider PV as negative. If you put PMT as negative, it will consider PV as positive. That's how the calculator functions. So you need to ensure that you are putting the right sign so that you get the right answer. Okay, so this is how you calculate PV. Now, assuming if it was this case that you wanted the cash flow at the end of every year, then what would have been the case? You simply had to change set from begin to end. When you do that, you simply go to PV and press solve. When you do that, the answer that you get is 1,89,539. So 1,89,539. This is beginning, this is end. Logically, if you see that the numbers between the numbers with begin and end is different. Now, the number that you get with end is definitely lesser than what you get with beginning. The reason for this is, if you look at this cash flow, if you put 2,08,493 immediately, and then you're withdrawing 50,000 immediately, you're not letting that compounding work. Okay. So the moment you're putting 2,08,493, you're immediately withdrawing 50,000 rupees, and then you're letting the remaining amount on some interest. But here, when you are putting 1,89,539, you're letting this entire amount on interest. Okay. And that's how the requirement comes lesser. So I'm going to show this to you in Excel also in a couple of minutes. Okay. So PV is how you calculate over here with beginning and with end. Please note this down, the steps, and then once you're done, you confirm. So I'm just putting what happens in case if it is set end. So set end remains same, 5, I remains same, 10, PV is something that you need to find. PMT is 50,000. FE is 0. Payment per year is 1. Compounding per year is 1. Okay. And the answer that you get is this one. And the answer that you get here is this one. Okay. So quickly make a note, and I will show you how this works in Excel. Okay. Plus, I will also explain to you what this statement means. The higher the discount rate, the lower the present value of the annuity. Okay, so assuming you're done writing, now I'm going to show you how to calculate this in Excel with the help of a formula, and how do we get the same answer. And plus, I'm also going to explain to you what happens in the background. Okay, how if we are getting this answer automatically, what really happens in the background, that I'm going to demonstrate in Excel. So let me, okay, so I'm just zooming this so that you are able to see. So what we wanted to calculate was present value, okay, wherein the cash flows requirement was 50,000 every year for the next 5 years with an annual rate of 10%. So whenever you want to calculate a present value, you press this equal button and then type PV. When you type PV, either open the bracket or either press the tab button. Okay, when you press the tab button, the bracket opens, or you can simply type PV and open the bracket. When you open the bracket, it will prompt what inputs you need. So you need first the rate. Now, what is the rate? The rate is 10%. So put 10%. Once you put the rate, press comma. Then it will ask you what is N per. N per is the number of payments. So how many payments you require? You require 5 payments. After you put the number of payments, press the comma button again. Then it will highlight PMT. What is PMT? It is 50,000 rupees. Okay. So 50,000 rupees. Okay. Now, since this is an inflow, 50,000 rupees will be positive. Then after PMT, it asks you what is the future value. Now, what is the future value? 0, because after 5 years, you don't need anything. And then after future value, it will ask you type. So if it is begin, it will ask you to type 1. If it is end, it will ask you to type 0. So we will do the calculation with begin first, then we'll do the calculation with end later. So let's type 1. 1 will give you the effect of begin, and then press the bracket close key and press enter. If you see, the answer that you have got is 2,08,493, which is exactly the same that we got over here. I've not put the decimals, but the decimals are exactly the same. Okay, so this is how you calculate the PV. Okay, so I'm just meant. So you can take a picture of this or maybe a screenshot, whatever you want to take, so that you can refer to this. When you do this practice on your own in Excel, you can refer to this. Okay, assuming that you're done taking the picture. Now, what do you do here? This is with begin. Okay, now let's calculate with end. What you simply do is just change this 1 to 0. When you do that, you'll get the answer as 1,89,539.34. And this is exactly the same that you get over here. So it is 3385. If I just increase the decimals by 2 decimal points, can you see over here? You get exactly the same 189,539.3385, which is the answer over here. So this is with set end. Okay. The reason you're seeing a red color number because this is negative. Okay. So what I simply do is if I don't want the negative number practically, okay, because if you're presenting this in front of the client might not understand the negative and the positive side of the cash flow. So what I simply do is whatever is the PMT, I just keep it as minus. When I do that, a negative number changes into positive. This is from a practical perspective. When you're showcasing this to the client and you don't want to show the negative number, then you can do that. So that either you can do a minus 5,000 or you can put a minus sign to the PMT, or the other way also, what you can do is you can just type a minus over here. Okay, minus PV. That is also something that will give you a positive number. So then it makes sense to explain to the client. So simply add a minus before PV and that negative number converts into a positive number. Okay. Now let us understand what happens at the back end. Okay. Now there is this way of calculating this. Then there is another way to calculate this in the cash flow function. So I will also show you how that works. Okay, so 50,000 is what you need for 5 years. Okay, you want to find out the present value. How do you do that? So there is another formula called as NPV, that is net present value. Okay, in NPV, you have to use the rate. Now, what is the rate? Rate is 10%. And then you have to use the cash flows. So just select all the cash flows and press enter. And you get this 1,89,539. The challenge with NPV is that the answer that you get is considering that the cash flows will be withdrawn at the end of the period. That's where you will see that this cash flow and this cash flow is exactly matching. Okay, because by default, NPV formula considers that it is the cash flows are happening at the end of the period. But let's say you want the beginning effect. Then what you simply do is, if this is the end effect, what you simply do is you calculate this and simply multiply it by 1 interest rate, which is nothing but 1 plus 10%. Okay, so whatever is that number, just multiply it by that number, and that is how you will get this number and this number matching. Okay, because there is one lesser interest taken over here. Here you need to add that interest back so that you get the begin answer. Okay. Now let us understand what is happening in the backdrop. How are we getting this number? Like, is this something that really will ensure that 50,000 rupees is received every year? Let's see that. Okay. So let me just put it over here. Let me put beginning corpus, then you put cash flow, then you put ending corpus. Okay, so cash flow is straightforward. 50,000 rupees is required for 5 years. Let's say you start with this number, which is 1,89,539. Now, since you need this cash flow at the end of the period, what will happen is this will earn what return? 1 plus 10%. Okay, so this entire corpus will earn 10% return. And after that, at the end of the year, this 50,000 rupees will be deducted. So at the end of 1 year, the cash flow that will be remaining is 1,58,493. So the value that you have at the end of first year is the same value that you have at the beginning of second year. Okay. Then what will happen in the second year? In the second year, again, this into 1 plus 10% minus the 50,000 rupees. Okay. So at the end of second year, this is the corpus that will be remaining. So since we have done it for 2 years, we simply drag it. And if you drag it, if you see that after the end of 5 years, the amount will be 0. Isn't this interesting? Okay. What I simply did was I just had the interest earned before, and at the end, the cash flow was withdrawn. Now, this is assuming cash flows are withdrawn at the end of year. Okay. Now let's see what happens if the cash flows are withdrawn at the beginning of the year. Okay, so here, what was the corpus that we calculated with beginning of the year? This was the corpus. Okay. Then what was the cash flow required? 50,000 rupees, and that was for 5 years. So in this case, what's happening is the moment you're investing, immediately 50,000 rupees is getting withdrawn, and whatever is the balance on that, you are earning 10% return. So at the end of 1 year, the corpus that is remaining is 1,74,342.60. Whatever is the corpus remaining at the end of 1 year is the same corpus at the beginning of second year. So you will simply select this and press enter. Then what you will do next year is this amount minus 50,000 rupees, and whatever is the balance, that will earn 1 plus 10% return. Okay. And then once you've done it for the second year, simply click here, double click here, the formulas will get dragged. Double click here also, the formulas will get dragged. And that is how at the end of 5 years, even with the beginning corpus, that becomes 0. Okay, so both the corpuses are different. Just because there's a difference in the timing of the cash flow, the corpus requirement is different. Okay, but both will become 0 at the end of 5 years. The return being same, it's just the timing of the cash flow will make a difference in the amount of money that is required. Now, if I just go back and talk about this point, the higher the discount rate, the lower the present value of the annuity. What this means is, assuming that instead of 10%, if the rate was 15%, okay, the rate of return was 15%. See what is happening. So earlier, what was 2,08,000 for beginning, now the corpus has gone down to 184. Earlier, what was 1,89,000 for the set end, it has gone down to 67. So more the return, the lower will be the present value. Now, if you read this, it makes sense. So let us read this statement again. Present value of an annuity is the current value of future payments from an annuity given a specified rate of return or discount rate. So I told you that rate of return is also sometimes called as a discount rate. The higher the discount rate, the lower the present value of the annuity. Okay. So I hope you have understood this. Then the second point says future value of an annuity is a measure of how much a series of regular payments will be worth at some point in the future, given a specified rate of interest. Okay. Now, how do we calculate this? Like we calculated the present value, you can also calculate the future value. Now, assuming that instead of you having that 50,000 rupees of cash flow, let's say you are thinking of investing this 50,000 rupees for 5 years. Then how does the math work? So what is happening? You're investing this cash flow and you want to calculate the future value after 5 years, assuming the rate of return is 10%. Then how do we calculate? What you simply have to do over here in the compound function, assuming that the cash flows are invested starting today. So set will be begin, N will remain 5 because there are 5 annual investments. I will be 10%. PV will be 0. Since now you want to find out the future value, PMT will remain the same. FE you need to calculate. Payment per year remains 1. Compounding per year remains 1. Go to FE, press this solve button. What you're getting is 3,35,780. The reason you're getting this as negative is because we have not put the PMT as negative. Since this is a cash outflow, PMT should be negative. Now, how do you make the PMT as negative without deleting this number? Either you can, type minus 50,000 rupees and press enter, or you can simply insert minus sign over here. How do you do that? Press the right scroll key. So it will take you to the beginning of this number. So it works a little different over here. If you press the right scroll key, it takes you to the left beginning. If you press the left scroll key, it takes you to the end of the number. Okay. Since we want to go to the beginning of the number, you need to press the right scroll key. It will show you the cursor over here. Simply put this minus sign and press enter. This is one way, or you can simply overwrite it like this and press execute. But it's important that you save time. So these are the shortcuts that you need to know. Now, since this is a cash outflow, you have put this as minus 50,000 and future value you need to calculate by pressing 0. You will get the same answer. The only difference being a minus will now show a positive number. So 3,35,780.50 is the answer. 3,35,780.50 is the answer if the cash flows are invested at the beginning of the period. Now let's see what happens if the cash flows are invested at the end of the period. What you simply have to do is go up, just change the set from begin to end and press execute. Then scroll down and go to FE, press solve. So you will see that the answer that you're getting is 3,05,255. So 3,05,255 5,255. So this is the answer that you get if the cash flows are invested at the end of the period. Okay. So how do we do this in the Excel? Again, pretty simple. So what you do here is use this formula called as FV. Just like you have PV for present value, you have got FV for future value. Okay, FV, open the bracket, it will prompt you to put rate. Rate is 10%. It will prompt you to put the number of payments, which is 5. It will prompt you to put the amount of payment, which is minus 50,000, because this is an outflow. It will prompt you to put present value. Since nothing is invested one time today, it will be 0. Then it will prompt you to put whether the investment is starting today. If yes, press 1. If it is starting later, then press 0. So since we want to find out the future value, assuming the cash flows start today, so press 1, close the bracket and press enter. So when you do that, you get 3,35,780.50, which is exactly the same that we got over here. Okay, I just will put the decimal. Okay, so this is with beginning. Similarly, if you want to calculate with end, what you simply have to do is just change this 1 from, just change this 1 to 0. When you do that, you get this 3,05,255, which is exactly the same that you get over here. 3,05,255.00. Okay, so this is how. So just like we have the net present value formula, we do not have a net future value formula. So if you want to just see what is happening at the back end, let's see what is happening. Okay, so I will just copy this and paste it over here. Okay, so let's say your beginning corpus is 0, your cash flow is 50,000. Okay, now what's happening is ending corpus will be, assuming that you are earning the interest right from the beginning. So it will be this into 1 plus 10%, close the bracket. So at the end of 1 year, this will be the value. Whatever is the value at the end of 1 year will be the value at the beginning of the second year. Second year also you are putting the cash flow. So here it will be this plus this into 1 plus 10%. So at the end of 2 years, this will be the value. Then end of 2 years, whatever is the value at the beginning of the third year. Again, you're putting some cash flow over here. Again, you are adding this plus this into 1 plus 10% and close. Okay. So you simply drag this for 2 more years, and this is how you're getting the answer. Okay. The reason you're getting this answer is because here, since I dragged it, the number changed a little bit. Now, if you see, if I make it all 50,000 rupees, so I'm getting 335,780.50. This is how the things are happening in the background. Now, if I want to give the same effect for a set end, what I simply have to do is, now here, since I'm beginning the cash flow at the end of the year, I will not be earning any interest over here, right? So I will just remove this 10%. Okay. So what's happening here? So you're getting this return. So 50,000 plus 50,000 plus 10%. So you're getting this return. Okay. And then what you are doing is this thing. Okay, so here you are ending with only 50,000 rupees. So 50,000 is what you're adding, and this plus this will earn 10%. So at the end of second year, you will have 1,10,000. At the beginning of, or at the end of third year, you'll have 76. End of fourth year, you'll have 76. And then what will happen is in this example, what will happen is a little different. So this 2,48,000 will earn 10% interest. Okay. And simply that 50,000 rupees, which is the last cash flow, will get added. That's how you are getting. 1 second. What's the problem over here? Just a moment. Let me just see what went wrong. Okay. So now I understood. So what has gone wrong is only this is earning return. So bracket open, this plus, sorry, this into 1 plus 10%. Okay. Plus 50,000. So what's happening is, since you are investing this at the end of the period, so second year, what will happen is that at the end of second year, only 50,000 rupees is going to earn 10%. This 50,000 is simply going to get added. So at the end of 2 years, it will be 1,05,000. Similarly, at the end of 3 years, I will just simply copy paste this. Okay. And you will see that now it is matching. So 3,05,255, okay, is what you have at the end of 5 years. Because the reason why you have a different number here is because at the end of 1 year, if I just simply show it on a timeline, so this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. If you're investing 50,000 rupees every period, so what's happening is you will get interest for this period, this period, this period, and this period. So for 4 years, you will earn interest. You'll earn interest for 3 years, 2 years, and 1 year. And here you will not earn any interest because the moment you're withdrawing this, the moment you're accumulating, you're simply adding this 50,000. So this will not earn interest for any period. So this will earn interest only for 4 years. That is between 1 and 2 year, 2 and 3 year, 3 and 4 and 4 and 5. This will earn interest only 3 years, and so on and so forth. And that's where it's only coming to 3,05,255. Okay. So this was all about calculating the time value of money different ways in Excel as well as in calculator. I hope you've understood this. Okay, so now before we do some calculations, we'll understand the two different types of annuity. So annuity, by now, I hope you know, annuity is nothing but a pension plan, or it could be any stream of income that is received over a period of time. Either you make that payment or whether you receive that payment. Okay. So the two subcategories of annuity is, one is called as ordinary annuity. The other one is called as the annuity is due. The difference between the two is that in case if it is an ordinary annuity, you need to take set as end. Okay, whenever you are dealing with ordinary annuity, you have to take set as end. Whenever you are seeing this annuity due, then in that case, set will be begin. So anything which is due today, set will be begin. Anything which is not due today, which is called as ordinary annuity, there you will take set as end. So this is something that you'll have to keep in mind. So the examples over here is where, in case if you have invested in a bond, the interest that you typically get in a bond is at the end of every period. So if it is an annual coupon paying bond, you will get it at the end of 1 year. If it is a half yearly coupon paying bond, you will get it at the end of 6 months, so on and so forth. So that is an example of an ordinary annuity. In case of an annuity due, you have an example wherein you're paying rent to a landlord. So there you have to pay the rent in advance. You cannot tell to the landlord that I'm moving into your place and then I will pay you the rent at the end of every month. Okay. You need to start by paying the rent in advance. So that is an example of annuity due. Again, in case of investments happening today, that's an example of annuity due. In case of any loans, that is an example of ordinary annuity. So assuming that you've understood the difference between ordinary annuity and annuity due, you've understood when to take set as begin and when to take set as end, we will move on and do the calculation. So there are some practice questions that we'll be doing so that the concept of the time value of money becomes more clear. So in this example, Rekha wants to invest 10,000 rupees every month, starting today for the next 7 years to accumulate money for a car purchase. Assuming she earns an expected return of 12% per annum, compounded quarterly, what will be the corpus created? Okay, so these are the numbers that you have. Now, I want you to take 2 minutes and just write the inputs as per the compound function. What will be the inputs? And then we will solve this in calculator as well as we will solve this in Excel as well. So take 2 minutes, solve this, and then we'll come back and see what the inputs and the answer should be. So don't solve it, basically write the inputs. Okay, let's see what the input should be. So set will be begin since nothing is mentioned. N will be 84. Why 84? Because if you see, it is a recurring cash flow invested every month for the next 7 years. So in 7 years, there'll be 84 monthly payments. So N in case of recurring cash flow will be the number of payments and not number of years. So some of you have mentioned N as 7. That is not correct. So N has to be 84. I is 12 because 12% is the return which is compounded quarterly, but you will take the annual nominal rate, the compounding frequency, you will give it somewhere else. PV is 0. PMT is minus 10,000. Since 10,000 is the recurring payment and since it is an outflow, it has to be in minus. FV is what you need to calculate. Payment per year is 12. Compounding per year is 4. Okay, so this is what will be your input. Let's do this in the calculator and see what the answer should be. So set is begin, N is 84, I is 12, PV 0, scroll down, PMD will be minus 10,000, FV 0, payment per year 12, compounding per year 4. Okay, so that's how you will input this and then go to FV, press solve. What you should get is 13,13,601. 13,13,601. This is your answer. Okay, note this answer down. When you get access to the calculator, you can solve this and see if your answer is matching. Okay, now what we need to do is calculate this, learn how to calculate this in Excel. Okay, Okay, now we want to calculate the future value. The problem here is that the frequency of the payment is monthly and the compounding interest is quarterly. Okay, so we need to ensure that the payment frequency and the compounding frequency kind of matches. Okay, so how will that work? So first you need to calculate. So in Excel, you need to be careful. You need to calculate the effective rate of return. Calculator, it becomes simple because you have a field. In here, in Excel, you don't have a field for payment per year and compounding per year. Okay, so you need to do some adjustment in Excel. If you understand this, good. If you don't understand this, you continue solving such question in the calculator, which is straightforward. Okay, so I'll explain how to calculate this in Excel. So first, you need to calculate the effective return of that 12% compounded annually. So how do you calculate the effective return? It will be simply 1 plus 12% divided by 4 divided by 100%. Okay, if you remember, 12% is quarterly compounding. So you need to divide it by 4 quarters and then raised to 1 into 4. That means in 1 year, there are 4 compounding periods. When you do the math, what you're getting is 1.1255. Okay, this becomes your the answer, minus 1. And then this into 100 will give you 12.55%. So what is this? This is the effective return of 12% compounding quarterly. Now, the next thing that you have to do is that this effective return is annual and your payments are monthly. Okay, so you need to match this and see if this is the effective return, what will be the monthly effective return. Okay, so what you do is that you calculate the monthly effective return. If 12.55% is the annual effective return, what will be the monthly compounding kind of a return? So it will be 1 plus this divided by 100 raised to 1 divided by 12. Okay, so if you see over here, it is 1 plus 12.55% divided by 100. So 12.55 is in numbers, divided by 100 will get converted into decimals, plus 1, and then raised to 1 by 12. Why 1 by 12? 1 divided by n is nothing but the compounding frequency. So you're trying to find out what is the monthly effective return. Okay, so that number comes to 0.99%. Okay, so this is the monthly effective return. I know it is a little longer to do it in Excel for this thing, so you need to have practice, but I'm just showing you that if you want to do it in Excel, it is quite possible, but you have to do some adjustment. In calculator, it is pretty straightforward. Okay, so now let's do the calculation. So future value is equal to rate. So this is the rate. Put a percentage sign since there is no percentage sign over here, comma, number of payments. How many number of payments are there? 84, comma, how much amount you're investing? 10,000. And since this is an investment, it will be minus 10,000, comma, do you have a present value? Any one-time payment? The answer is no. So it will be 0. And then type will be 1 because you're considering that the payments are starting today. When you do that, you get this answer. That is 13,13,601.63, which is exactly matching with what you have in the calculator. 13,13,601.63. Now, assuming you don't do any of such adjustments, then your answer will be something incorrect. Okay, so in Excel, some cases it becomes very, very straightforward. In some cases like this, you need to, where the payment frequency is different, the compounding frequency is different. So you need to adjust the interest rate to match it with the payment frequency and then calculate this. Okay, I'm going to share this worksheet with you, which will be available for download so that you can refer to this Excel sheet later to see all the formulas. Okay. So assuming that you've understood this, the answer we have got. Let's move to question number 2. So question number 2 is where Rakesh wants to have a monthly income of 25,000 at the end of every month for the next 15 years. Calculate how much he needs to invest now, assuming he earns 7% on his investments. Okay, please calculate. You can pause the video, calculate, and tell me your answer in the chat box. Let's see how to solve this. So first look at the steps. So set will be begin, N will be, since the monthly income is required for 15 years, so N will be 180. I will be 7% per annum. PV, you need to find out. PMT is 25,000. Set should actually be end, because if you see 25,000 is required at the end of every month. So by mistake, I have put begin, but it should be end. And then PMT should be 25,000, which is the income. FV should be 0. Payment per year should be 12. Compounding per year should be 1. This is from a practical perspective. From the examination perspective, ensure that you follow this practice wherein the C by Y will be equal to P by Y. Okay, the answer will be slightly different. Okay, this is, I'm talking from a practical perspective. So now if these are your inputs, you need to calculate what is the PV. So let's do it in the calculator. Go to CMPD function, set change from begin to end, press EXE button, choose option number 2, press EXE again. So your set is changed to end. N will be 180. So 15 years into monthly payments is 180 payments. I will be the interest rate, which is 7%. PV is something that we need to find out. PMT is 25,000. Then FE is 0. Payment per year is 12. Compounding per year is 1. Once your inputs are correct, go to PV, press this blue color button solve, and you'll get the answer as 28,18,967. 28,18,967. Okay, is the answer. Now, if you have to do this in Excel, how do you do this? Since the interest rate is 7% compounded annually, you don't need to find out the annual effective return, because 7% compounded annually, the effective return is also 7% compounded 7%, right? So what you need to do is you need to calculate the monthly effective return, since the cash flows are required every month. So how do you do that? It is 1 plus 7% divided by 100% raised to 1 by 12 minus 1, and this into 100. So the monthly effective rate comes to 0.56%. Okay, this is the monthly effective rate. So now you need to calculate the corpus required. So PV is equal to the rate, put a percentage sign, comma, 180, comma, PMT will be 25,000, comma, FE will be 0, comma, set will be 0. Okay, type will be 0 because you need the cash flow at the end of the period. So this will be 0, and then close the bracket and then press enter. You're getting 28,18,967. Since you have to invest this amount, that is why it is showing as negative. In Excel, if you just want to show it as positive, just put a minus sign in front of PV, and this number will get converted into a positive number. So 28 lakh 18,967 is the answer that you get in Excel as well, which is exactly matching with what you see over here. The only thing you need to remember is that you need to convert the annual interest rate into the payment frequency. So payment interest is compounded annually, payment is monthly. So you need to calculate what is the effective monthly rate. This is what we have done. I can simply use a formula and directly calculate rather than doing this. So how do I do that? So it is PV. Then I can open a bracket 1.12, that is 1.07, that is 1 plus 7%, raised to 1 divided by 12 minus 1. Then I can put the number of payments, that is 180. Then I need 25,000 rupees per month. FE 0, set is end. And when I do that, I still get the same answer. But what I've done is I've solved the rate in the formula itself. Okay, here I've shown it differently, but here I've solved the rate in the formula itself. So if you know how to do this thing, then Excel is something that will be very easy. But till the time you don't get used to this, try practicing it and try doing this first in the calculator and then see whether what you're calculating in the Excel, the answer is matching with the calculator. And the day you start seeing that the answers are matching in Excel and calculator, that means you're an expert that day. Okay, so that's how you can practice and get this done. Okay, so assuming that you're okay with question number 2, let's move to question number 3. So question number 3 is where Suresh, who just retired, has received a lump sum retirement benefits of 60 lakhs. He would like to buy an annuity plan for 30 years, which is providing him a guaranteed annual return of 6% with capital liquidation. Calculate what should be the expected monthly cash flow to him over the next 30 years. Okay, this is the question. So pause the video. I'll give you 2 minutes and calculate, at least put the inputs. If you don't have the calculator handy, just put the inputs and later on you can calculate. So after 2 minutes, I'm going to show you how to solve this. Okay, let's see what should be the inputs. So since this cash flows are required, calculate what should be the cash flow to him, capital liquidation. So assuming that here it's not mentioned whether the cash flows are required at the beginning or the end. So in this case, usually it should be considered as beginning. So set is begin. N will be the number of cash flows. Since this money is required over 30 years on a monthly basis, so N will be 360. I will be the rate of return, which is 6%. Then PV is something that he's going to invest. So it will be minus 60 lakhs. Since this amount of money is going to get invested. PMT is something that we need to find out. FV is going to be 0. Why? Because it is mentioned that it is a capital liquidation method. And then you have compounding per year. Sorry, you need to have first payment per year. So payment per year is 12. Compounding per year is 1. Remember, from the examination perspective, it will be 12, but practically it will be 1. So you have these inputs and then you put it in the calculator and press solve. So let's do that. So let's change set to begin by pressing the EXE button. N will be 360. I will be 6%. PV is minus 60 lakhs. PMT is 0. FE is 0. Payment per year is 12. Compounding per year is 1. Scroll up, go to PMT, press the solve button. When you do that, the answer that you get is 35,190. So 35,190 is the answer. Okay. So some of you have got the right answer. That's fantastic. If you have to do this in Excel, how do you do this? Let's see. So I'm going to directly put it over here. So PMT. So now you're calculating the PMT. All right. So PMT is when you're calculating the payment. The rate of return is 1.06 raised to 1 divided by 12 minus 1. Close the bracket. You need the payments for 360 months, comma. What is the present value? It is minus 60 lakhs. Future value is 0. And then you need the payment at the beginning of every month. And that's how you get the answer as 35,190.93. So this is how you get the answer in Excel. Okay. So I hope you're enjoying doing this calculations on the calculator and in Excel. Okay. Then we come to the second last question of today's session, wherein Naresh wants to invest rupees 20 lakhs and have a quarterly cash flow over the next 15 years, wherein he would like to retain 5 lakhs at the end of it. Calculate the amount of money he can receive, assuming he earns 10% per annum on his investments. Okay, this is a little tricky. Okay, let's see how do we solve this. So we first see the inputs. So set. Now what should be set? Now here he needs quarterly cash flow over the next 15 years, but the frequency, whether the cash flow is required starting today or at the end, is not mentioned. So let's assume it is begin. In the examination, choose both set begin and set end and see if you're getting the right answer. It's just a one extra step that you need to do to ensure that you get the right answer, because there is some bit of ambiguity in the examination. But practically, if you don't see any frequency mentioned or when the payments are going to be made or received, whether today or later, then take it as set begin. N will be the number of payments. So since the cash flows are required quarterly and these cash flows are periodic in nature, so in 15 years, there will be 60 quarterly payments. In 1 year, there'll be 4 payments. In 15 years, there'll be 60 payments. So N will be 60. I will be the rate of return, which is 10%. So let's put 10% over here. PV is the amount of one-time investment, which is 20 lakhs. Then what you need to calculate is the amount of periodic cash flow, which is PMT, which is question mark for now. Future value, should it be 0? The answer is no. Why? Because he needs 5 lakh rupees at the end of it. So in this case, 5 lakh rupees should be the future value that should be remaining. And then what you have is payment per year, which will be 4. And if you see over here, if you divide the 60 by 4, the calculator knows that this investment is for a period of 15 years. And then compounding per year, since we do not know the compounding, so by default, take it as 1. But from the examination perspective, take this as 4, which should be matching with P by Y. Okay, so with this inputs, let us calculate the answer in the compound function. So set is begin, N is 60, I is 10, PV is minus 20 lakhs, PMT for now 0, future value 5 lakhs, payment per year is 4, compounding per year is 1. Scroll up, go to PMT, press solve. So the answer that you get is 58,208. So 58,208. Okay, is the answer. Now, can we do this in Excel? Of course, yes. Anything that can be done in the calculator can also be done in Excel. So how do we do this? PMT, open the bracket, 1 plus 10% is 1.10. Do a raise to 1 by 4 now. Why 1 by 4? Because you need to match the effective return matching the cash flow frequency. So cash flow is paid every quarter. So earlier we used to have cash flows every month. So that is the reason we used to do 1:12 or 1 divided by 12. So here it will be raised to 1 divided by 4 because we need that quarterly effective return. Minus 1, then comma, then the number of payments are 60. then put a comma again, then present value will be minus 20 lakhs, put a comma again, then future value will be 5 lakhs, put a comma again, and set will be 1. Close the bracket and see the answer. So you're getting exactly 58,208. Okay, which is exactly matching with what you see over here. Okay, please make a note of this quickly, of these inputs, and later on you can solve it on your own. Assuming that you are done copying this, let's move on to the last question for today. So Sujata wants to have a yearly income of 3 lakhs for education of her son for 5 years starting next year. If she can invest 12 lakhs now, then what is the return that she should target on her investments? Okay, this is what you need to calculate. All right. So let us do this again together. If she wants the money starting next year, okay, so 3 lakh is the cash flow requiring next year. So how do you give this effect? So set will be end. N will be the number of cash flows. So she needs money for 5 years. So N will be 5 annual payments. I is something that you need to calculate because you don't know what is the return that should be targeted. Then PV is the amount of money that she is going to invest today, which is 12 lakhs. And since this is an outflow, it should be mentioned in minus or negative. So 12 lakhs is an outflow. PMT is positive 3 lakhs. Since this is going to be an inflow. FV is 0. Payment per year is 1. Compounding per year is also 1. So you need to calculate what is the interest with this as the input. Okay. So let's do this in the compound function. Let's go to set begin and change it to set end because the cash flows are required starting next year. So set is now end. N will be 5. I will be the rate of return that we need to calculate, which we don't know. So put 0 for now. PV is minus 12 lakhs. PMT is 3 lakhs yearly. FE is 0. Payment per year is 1. Compounding per year is also 1. Once you have these inputs ready and you've verified it, go to I percentage, press solve. So that answer comes to 7.93%. Okay, that's the answer. 7.93%. That's the answer. Now, can we do this in Excel? Of course, yes. So how do we do this? So you need to go to Excel and use this formula called as rate. Okay. So once you put rate, open the bracket. You need to put the number of payments, which is 5. You need to put the amount per payment, which is 3 lakhs in this example. You need to put the present value, which is 12 lakh rupees of investment, which should be in minus. Future value should be 0. And then since this set is end, you need to type 0 again and close the number. Okay. And close the bracket and then press enter. You're getting 8%. So just increase the decimals and you will see that the return is 7.93%, which exactly matches with what we have over here. Okay. So please make a note of this and do this calculation on your own and see if you're getting the same answer. Okay. With this, we end today's session. Please practice this. I will be giving you some practice questions so that you can use those questions and you can practice whatever we have learned today.